Manometer is a pressure measuring device. It is used to measure pressure of gases in closed containers. Some examples of gases in container. A student normally think that it should be a thing that looks like a pressure cooker, but actually it is not that case. A gas container can be a balloon. A tire on your car is also a container that contains gas. Air is a combination of gas, so it is a gas. And this is the gas cylinder that we have at homes for giving gas to the stoves or burners. Not the actual drawing, but this is the best I could do. Now, these are examples. There can be many other examples of any trapped gas. It can be a perfume bottle, because that is also a gas. As soon as you let the gas come out, it comes out by itself. A spray paint, that is an example of gas contained in a container. Now, these are examples of some containers that have gas. Some containers have very high pressure gas. For example, this tire. It has a large pressure, so if you let the air come out, it will come out with huge pressure. These balloons, they have comparatively lesser pressure. They have a mediocre pressure, more than balloon but less than pressure in a car tire. What device we can use to measure these pressures? This is where the manometer comes in. It is a simple U-shaped glass tube which is filled with a liquid. That liquid has two surfaces in one part of the manometer and the other part of the manometer. It is better, so I draw a diagram for you guys so you can actually see how does it look. This is how a manometer looks. It is a glass tube, open on both ends and filled with a liquid. Which liquid? Which liquid should we use? The liquid has to be selected on the basis of how much pressure you are supposed to measure using that manometer. Liquid in the manometer affects the sensitivity and the range at the same time. If you increase sensitivity, that will reduce range, and if you increase range, that will reduce your sensitivity. But high range will allow you to measure larger pressures, and higher sensitivity will allow you to measure very small differences between pressures or very small pressures. This detail is written over here as a note that there is a note. To measure small pressure like pressure of air in balloon, a liquid with low density is more practical. This will increase sensitivity, so you can measure very small pressure differences or pressure, and consequence is that the range will decrease. So if you're using a low density liquid like water or paraffin or alcohol, so if you're using that kind of liquid, what will happen? The manometer will be very practical for small pressure differences or pressures, but it is not good for a large pressure, because as you use less density liquid, the range of the manometer decreases. You cannot use it for very large pressures. And opposite happens if a liquid with high density is used. So if you need more range, just throw this liquid out and replace this liquid with a high density liquid. What will happen? A small pressure will make very small difference, but if you use a larger pressure, it will produce a significant difference between the levels of liquid in both sides or arms of the manometer, and you can measure that pressure. How do we do that? Let's see. Let me draw some new diagrams, and we can see how this manometer works. Here we go. This is a gas container, the same container I drew over there, but this is now laying horizontally. This is the nozzle from which the gas comes out. This is the wall, and I have connected one end of the manometer and tighten it, fasten it with something, so no leakage is happening over here or over here. And I have connected it using a flexible pipe, so that can send air from the gas container, or gas from the gas container on this side of the manometer. As soon as I open the valve, what happens is the gas from the gas container comes, hits the water or liquid particles over here. So what happens is the liquid on this side goes down and liquid on this side goes up. This is a scale that we use to find out the height difference on both sides. But remember one thing, it is not the liquid on this side alone that is compensating this gas pressure. There is one other pressure acting over here that we cannot see in the diagram, but it is always there, and that is atmospheric pressure. The atmospheric pressure is acting over here, which will be pushing this liquid down on this side. Now, if you only find the pressure exerted by this much liquid, this will be the excess pressure. What is meant by excess pressure? Excess pressure is pressure above atmospheric pressure. So how do we calculate it? We measure this height, we know the density of the liquid, and you use the formula rho GH to find this excess pressure. But this is not the pressure of the gas. This is the pressure above atmospheric pressure. If you need the pressure of the gas, what you have to do is you have to add this excess pressure to the atmospheric pressure. That will give you the total pressure of the gas. Okay, so this is how we use manometer. We connect one side to the device that we want to measure the pressure of, and then we see how much it goes up. And now I think you should be able to understand that we can use manometer to compare gas pressure in two gas containers as well. If we connect the second container over here and we see the liquid is coming up on this side, it means this container has less pressure and this container has more pressure. But if the opposite happens and liquid goes up on this side and down in this side, it will be opposite as well. So this manometer can be used to compare two pressures, and in this case that I have illustrated in this diagram, it shows that we can use a manometer to measure the pressure of gas inside the gas container. This height gives you the excess pressure, and we can find this excess pressure by using formula rho GH, and the total pressure of the gas is this rho GH, which is the excess pressure above atmospheric pressure. So we add these two, and why we are adding, because on this side atmospheric pressure and this liquid pressure together, they are compensating the pressure of gas. So these two together are equal to gas pressure. So atmospheric pressure and excess pressure equal to total pressure of gas in the container. This is how we solve these questions. But we can have different kinds of gas containers in different circumstances. Some gas containers have a pressure, very high pressure, some have very low pressure, some even have vacuum in them. Like if the gas has been removed from the gas cylinder even when it was equal to atmospheric pressure. More molecules are removed from the gas cylinder. What happens in those conditions? In the last part of this lecture, we will be looking at that. Here's the last part. I have made three diagrams over here. A gas container connected to manometer, gas container connected to manometer, gas container connected to manometer. As you can see, there are three different situations. This one, as explained in the previous screen, when this happens, when the valve opens and this happens, it means the gas pressure in the cylinder is more than atmospheric pressure. And how we can find the gas pressure in the cylinder? It will be atmospheric pressure plus rho GH. And this is what we can see qualitatively, and this is quantitatively. Qualitatively, we can simply say the pressure of gas is more than atmospheric pressure. And if we need to find the value of pressure of the gas in the cylinder, it will be atmospheric pressure plus rho GH. What if this happens? We open the valve and the liquid does not change. It neither goes up nor goes down. That means the pressure of the gas in the cylinder is equal to atmospheric pressure. And this is also one of the possibilities. When we connect gas and open the valve, instead of liquid going down in this side and up on that side, it goes down on this side and up in this side. This means what? This means that the gas pressure in the cylinder is lower than atmospheric pressure. And how can this happen? It can happen if there is a partial vacuum in the gas cylinder. And level of the left side has gone down. This is illustrated in the statement over here as well. The conclusion is the pressure of the gas is lower than atmospheric pressure. And if you need to know the pressure of gas in the cylinder, it will be atmospheric pressure minus rho GH. So we subtract rho GH in this case. And what is H? Actually, I should have mentioned in the diagrams as well. It is this one, the height level difference in both sides of the manometer. This is height. Okay, this much height is used in this formula. These heights are actually from mentioned in the diagram. So this is what we do in using a manometer. This is how we use a manometer to measure pressure of gas in a container. And you must have seen this thing. If you have ever went to a tire filler for filling airs, and when they use that device that measure the pressure of the gas or air in the tire, that is actually a manometer. But normally in these days we do not use these analog manometers, we use digital manometers. They work a bit differently than this one, but they are manometers. If they are measuring pressure of gas in a container, they are manometers. There can be different kinds of manometers as well. Thank you for watching.